applications. Actually, you might be familiar about the word remote sensing. Is it all of you are familiar with the word remote sensing? It is the topic of the day and a GS application.
Yes, sir.
So how many of you can you just say?
Yes.
Yeah. Actually, remote sensing is a boon to the entire humankind. Why? Because we were having a great difficulty of getting data. Today, the world is information, the world of information. Getting data is a very huge task. And that too, especially the authentic data, is again another huge task. And when I started my research, getting any related information regarding the land or agriculture or anything, rainfall, temperature, everything, we had to go to the government office and we had to fetch the data from them. And whatever the data that they used to provide to us, it I don't consider that it had a valid one, and it is to be more authentic because it is all from person to person. The data has been captured, means from villages to village accountant to another person to likewise. By the time it comes to the actual records on the secondary publication, their data would have been modified and there would be a lot of errors in it. So this was the condition when we started our research in geography. I am from the field of geography and I am teaching geography and GIS and remote sensing and geomorphology, climatology. So this was the very terrible period, and we never used to get good results from the secondary data what we fetch from the government offices. But with the introducing of this remote sensing and the data that was available to us at present is really appreciative, and it is a great turnover. Means it has brought a big game changer in the information technology as well as development and planning. So data is required for all types of planning, whether it is agricultural planning or industrial planning or disaster management planning, urban planning, all types of planning. Land information is required. Land information means what is present at which place, whether it is water, where the water sources are there, where the land is good for agriculture, for what purpose that land has been used, whether we are using the right land for agriculture or the suitable land for agriculture is being turned up into a urban land or residential land. So this kind of a planning for land use, land cover planning, we need to have lot of information. Not only that, because see, we have three important information that is required for all types of planning. What are those three important data means? One is the land surface data. Land surface data means what is exactly the information that is available on the land, whether the human developed land or it is a natural land. What is the coverage? It means the land is covered by what? Whether the human developed covered land or it is a naturally covered land. So whether it is a water body or a road or it is a city or it is a agricultural land, in agricultural land, what type of a crop. So all this land information. So we call it as the land information. And another thing, what is required? The another information is about elevation data. Why the elevation data is required? Elevation data is required for to generate the DEM. DEM means digital elevation model. By the generation of digital elevation model, we get the 3D of our own land. How the land really looks over the earth surface. The same kind of a model we can digital elevation model we can develop through this software. So for that, elevation means each and every place elevation, even though it is available in the topographical maps which has been surveyed, Survey of India has got, but its interval is 20 meters. 20 meters interval we find. Whereas, sorry, actually 50 meters interval is there, 20 meters also there, but not for all the places, and there are some places where we do not have, and in places where we want to have the elevation data, we cannot just depend on the topographical map and digitizing it and generating. Even, yeah, it is possible to generate the DEM through topographical maps using the contours. But through the satellite, through the remote sensing, we get that information, the exact information of the elevation of each and every place at the level of 20 meters. Actually, earlier it was 30 meters. Much earlier than this, it was 90 meters. Now we get at the interval of 20 meters, 15 meters also. Means, the elevation data 15 meters means within the gap of 15 meters, there will be one point, A point and B point. What is the elevation? In between, it can be almost the same, or it may be little bit variation will be there. But 15-meter elevation data is a very good elevation information, because if you have 90 meters interval data, means within 90 meters there can be even a small mound or something. But this A point is 1000 meters and B point is 1020 meters, means in between it can be 1050 also. But now, because we get it at 15 meters, it will be very good information that we have. So this is helpful. This elevation data is helpful for preparing watershed management. Watershed management means we will develop a basin. Will develop a basin, because each and every land is geomorphologically created. Geomorphology created means either the river has been created, the land means by means of river erosion and deposition, or the wind would have developed erosion and deposition, and likewise the glacier. But where in the tropical region like our region, the river is the major denudation agent, and this river has created a different type of topography, and the each river has got its own basin. In the basin, there is a command area, and we find there is sub watersheds and sub watersheds. So this is very much important for developing a agricultural planning, because without having a watershed management and watershed area, we cannot develop agriculture. So agricultural planning is very much possible with the help of the DEM or the digital elevation model, because each and every stream path will be automatically generated through the DEM. So that is the major advantage of the elevation data. So I said that the surface information and the elevation information, and other information is about the climate or rainfall. Rainfall, temperature is a major element of climate, rainfall and temperature. So this element is also available from the remote sensing. So with these three types of information, we can make wonders, means in the field of planning. So that's how the remote sensing has become more popular, more useful, and it is highly contributing to the present day development. What we are seeing, the development in the span of last 20 years, we are having a tremendous change in the field of agriculture, and the production level is going, and we are having many lands are brought under horticulture, and many lands which were not, means newly identified lands are coming up for what crop it is suitable, because we come to know through these three types of information whether the soil of that land, the particular land, is good for cultivating a strawberry, or whatever the Mediterranean crop we have, whether that Mediterranean crop can be cultivated in our land or not. We can identify that, whether those suitable conditions are seen in our own area, in our own district, or in our own state. We can find and we can suggest the farmers or the landowner that this land is suitable for this type of a crop, why not you should go for it. So this is how the remote sensing information and GIS technology has brought a tremendous transformation in the field of all types of planning. I'm just talking about a few types of planning, but I'll be talking about the applications of the remote sensing and also GIS. So I think I have briefly given the importance of the remote sensing data. If you have any questions, you can ask me. Otherwise, I'll move on to the next. According to the slides, I'll just go on explaining. If you have any questions, because I given a very brief overview of the significance of the remote sensing. Yes, please. It's not audible. Can you speak? I'm not. Can you repeat your question, please? I'm not. It's not so audible.
ನೀವು ಸರ್ ಈಗ ಒಂದು ನಿಮಿಷ ಕೇಳ್ರಿ ಸರ್ ಒಂದು ನಿಮಿಷ ಕೇಳ್ರಿ ನೀವು ಪೇಂಟ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ರಿ ಅಂತ ನಾವು ನಾಳೆ ಒಂದಿನ ನಮಗೆ ಟೈಮ್ ಕೊಟ್ರೆ ನಾವು
somebody is going on conversation. Some of the participant is conversing with somebody else. Is it? Hello. Okay. Is it audible for others?
Yes, sir. It is audible.
Yes, it's audible. Yes, sir.
I do not know who is the gentleman who is talking over phone, and it is listening to me.
Sir, it is Ajay Kumar. Ajay Kumar, and one is
trying to mute him, but it's not possible for me to mute.
I think someone might be. We can take help of somebody, sir. They might mute. Only host can mute.
I just put him on the mute, but it's not working, I think.
I think Ajay is on still mic, sir. Ajay Kumar.
Okay. If you, is it clear for you, the others?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. If you need much more information, means I can give, but my presentation, my slides will be going to explain about the uses of whatever that I have given you in the introduction. So let me go on with because we are not going to touch about what is the type of satellite, what is the type of sensor, all those technical aspects we are not going to it, but only little bit of technical aspects I'm going to talk about, because some aspects is very much required for us to understand in order to know about remote sensing. So let me go with slide by slide. So you are seeing my slide. What is remote sensing? It is a technique of obtaining information about an object or area or phenomena from a distance. So remote sensing means, you know, that we have a remote control from in our home for television. So every human being is also having one remote sensing. Can you tell me which is that remote sensing we have?
The eyes.
Yeah, eyes. Eyes is the very good example of remote sensing. So without touching, without we can able to see the distance object, and we can understand what it is, whether it is a tree or it is a road or a building, anything, without going near to it and without touching it, we can able to see through our eyes. So remote sensing is just like an eye in the sky. It is a high in the sky. We have a satellite just like a eyes in the sky, and it is capturing the information of the Earth surface. So the Earth surface means, when I say Earth surface, means whatever the object that is found immediate to the on the surface, even 0.2 millimeters inside the information cannot be obtained. It is only the surface information. If one leaf is covering the underneath grass, means the leaf will come, but not the leaf information will come, but not the grass which is underneath it. I think you have understood. It is only the surface information. You got my point?
Yes, sir.
This is like our eyes. If one paper or object is sitting over the some land, means plastic paper or something, we do not know whether beneath that plastic paper, whether there is a stone or whether there is a grass or it is a open soil. We do not know. So just like our eyes, what is clear to our eyes. Similarly, because our eyes cannot see what is beyond the paper or the plastic paper, what is underneath the paper. So what we can see only the upper part of the surface, what it is covered with, whether it is covered by a paper or it is a grass or it's empty land with soil, red soil or blue or black soil. So whatever the type of soil that we see in our naked eye, the same information will be also sensed by the sensors. So there is no question of underneath information, but indirectly lot of underneath information is obtained. That is the beauty and the strength of remote sensing. So application of remote sensing goes beyond the surface information. It goes to the underneath of the land. Geological means we can explore the gold reserves or oil reserves or mineral reserves with the use of antivirus. So it will it is through different inferences we can make such type of underground information we can get. That is a different part of the techniques and learning. So just for your information, I said that the surface information only captured from the satellites, and the sensor will sense only those information. So why is remote sensing useful? It is useful because large regions can be observed over time. So if we want to survey the land and come, if we want to get the information of the entire state or entire district or entire taluk, it will take a long time and it is a laborious work. And whereas through remote sensing, we can get it within no time, because every day one satellite is going on and we can get the information. Sensor can measure energy at wavelengths beyond range of human vision. And another thing is that what human eyes can see, because our eyes can see, that is the difference between the remote sensing information and our eyes information. Our eyes can see only the objects that is in a physical form, but we do not see the temperature in our eyes. We cannot measure the temperature through our eyes. So we cannot measure the humidity through our eyes. We cannot measure the amount of or that is moisture present in the air. So likewise, we cannot. Our eyes has got certain limitations, but the sensors go beyond our human vision wavelengths. So that is another major advantage of the remote sensing, and records information in real time. So this is if somebody in the court also, if you go to the court, they say that eyewitness should be there, because unless the eyewitness is there, the case cannot be disposed for any kind of criminal act or whatever the type of act. As good as our own eyes, this is real-time information. What the satellite information is captured and we are using or seeing, it is totally a real one. There is no any kind of it cannot have different type of information of a particular land. So that is the major advantage, because sometimes a human being can give a wrong information, but not the satellite. So in this talk, I will be talking about the basics of remote sensing, types of satellites, and the type of data, and remote sensing data into GS, how we can use it for the geographical information system and planning. And finally, it can be focused to our own micro level and see from the global level to our national level to our state level to our own taluka or village level. We can get the information and plan for a very micro level land. So that is the major advantage of the remote sensing. So here is the how the remote sensing entire operation takes place. So we have two types of remote sensing, active and passive. Active is during night time. Passive, that is during daytime. The sensor which senses the wavelength emitted by the sun and which is reflected from the object. If it is captured by the sensor or satellite, that is called as the passive remote sensing. Whereas during the night time, the satellite itself will emit the light and it will capture the information. So that is active sensors, we call it as. So anyhow, it will come. Here we find the sun is the major source. Without the sun energy, they cannot be remote sensing. So A is sun, B is the wavelength that is emitted by this from the sun, and the surface is C, the land surface, and the whatever the wavelength that has been reaching into the surface, that is reflected, and the reflected rays is going back. You can see here, this is going back to the satellite. Means it is not going back, means it is going to the satellite. The satellite captures this wavelength. The reflected wavelength of an object will be captured by the satellite, and that captured information will be sent back to the the land station. Means the data that is captured from the satellite will be sent to the ground station, and the ground station will process this. So it can also communicate to another satellite, and also it will come from one D satellite to, it will go to another satellite and it will come down. And from the captured data station, it will go to the processing level. F is the processing station. The entire image will not be the type of image what we are seeing. It will be having a lot of noises with uncleared data. So that will be processed here and in the F. And from F, it will come to the user like us. The G is the final users. The G is final user. I think this is quite clear. If there is any question, please ask me. Hello.
Yes, sir.
Yes, sir.
Okay, okay. So this is electromagnetic spectrum. Means electromagnetic spectrum is the what we get through the sun's energy. Electromagnetic spectrum is the spectrum that is seen from the sun's energy. So the remote sensing is totally based on this electromagnetic spectrum. So the remote sensor collect the reflected and emitted energy from each and every object. So it will be reflected once the sun rays fall on an object, it will be captured by the sensor. Just like our camera, means we have our mobile phone camera or any digital camera does the same type of function, because when we click or when we take a photograph, the wavelength or the reflection that is there on each object, that the light or reflection, whether it is the natural light or sunlight, so it will be emitting the reflection. Each object reflects according to its tone. So our skin, if it is our face, according to the skin tone, it will be reflected, and that reflected wavelength will have a value. It will have a wavelength and as well as a value, and the reflected wavelength value will be captured by the sensor and it will be stored in the form of a pixel in our camera. The similar thing of operation is also performed by the satellite. It captures the emitted sun's energy, which is reflected, and that will be captured by the sensor. So electromagnetic spectrum has got the short wavelengths, which is including gamma and X-rays, and the longer wavelengths, including microwaves and broadcast radio waves. So we are not using all the wavelengths so far. We are using only a few wavelengths. We will be going to see about it. There are several regions of electromagnetic spectrum which are useful for remote sensing. Only few part of the spectrum is useful for remote sensing. So if you just look into this figure, you can see this wavelength. The wavelength is different. The wavelength that is coming from the sun as well as the reflected back to the satellite. That is also the wavelength differs because higher the temperature, shorter the wavelength, lower the temperature, longer the wavelength. And also the each color has got its own wavelength. So in that way, the wavelength differs shorter to longer. So visible spectrum means it is the spectrum which our eyes can able to see. That is the RGB or the VIB-GAIA. These are the 7 colors. All the 7 colors can be developed from RGB. That's why we call RGB colors. So that is VIB-GAIA is when we get a rainbow. Rainbow, you can find the 7 colors VIB-GAIA. So the 7 colors is the visible spectrum. Apart from that 7 colors, we cannot able to see through our naked eyes. So that is the visible. That's visible spectrum was used only. It was used in the earlier stages of the satellite technology, but now we are using the invisible spectrum also. So you can see here, this is the, in this figure, you have all these 7 colors, and the 7 colors have the different wavelengths starting from 0.4 into 10 to the point of 6 minus 6. So this is in the nano meters, and the wavelength are nanometers, and the visible spectrum is a very small part of the entire electromagnetic spectrum. Visible spectrum is very, very short. The arrow where it is showing, that is the visible spectrum. This is the part of the visible spectrum of the entire thing. We'll see in another figure. So as I already said, the wavelengths, the visible spectrum wavelength varies between 0.4 to 0.7 nanometers. The longest wavelength is red, and the shortest wavelength is it is blue and or violet. It is means the RGB we call it as blue as shortest wavelength, whereas in the VIB-GAIA we call it violet is the shortest wavelength, whereas the red is the longest wavelength. It is important to note that this is the only portion of the electromagnetic spectrum we can associate with the concept of colors. So our colors will recognize only these 7 colors. Other than the 7 colors, we cannot able to see anything else. So this is where we find, means it starts from here, this side. This is the longer wavelength. This is the shorter. Shorter to longer wavelengths. So again, what is the wavelength of each color? So 0.4 to 0.44 is violet, blue is 0.4462 green is 0.5 to 0.578, yellow, orange, red. So the red is quite a larger wavelength. And we see this visible spectrum through the prism. So this is what when the sun rays enters, it will create a visible spectrum like as we can able to see through this prism. So there is invisible range. What is 0.7 and above is invisible. So that region is called as infrared region. Infrared electromagnetic, in the electromagnetic spectrum, the infrared region is there. And from 0.7 to 100, we have 100 nanometers, and more than 100, it is it is not visible as wide as the visible portion. Means we have what we have the visible portion, 100 times of it is in invisible form. Means the portion what we have the visible spectrum, 100 times of it is in invisible portion. So the shorter wavelengths have properties similar to thermal infrared region, while the longer wavelengths approach the wavelengths used to radio broadcasting. Means it's all the radio and television programs. Everything is based on this wavelengths only. So the radio is also played through the wavelengths. And so if you see microwaves are there, and infrared. See, we have from 0, 7 in the 7 near to 7, and it's in the region of just nearer to 7. We find near infrared rays are there. Infrared, near infrared, short, mid infrared, short wave infrared. So likewise, the wavelengths which is invisible to us have a tremendous impact in the applications. So as I already told you, this is the passive sensor, and this is active sensor, where the sensor itself, satellite itself is what it is shedding light and getting the reflected wavelengths. And this is called as the geostationary satellite, which is used for our television telecast and other things. And the polar orbits or satellites are the satellites which are sending the land information. Land information means, as I told you, it will be for all the elevation data as well as land cover information, and also the thermal means temperature data and all, it will be sent. So what is the spatial resolution means? Actually, the satellites are stationed at, station means I'm not, actually geostationary satellites are stationed looking at one particular point on the ground. That is geostationary satellite. It will be more than 30,000 kilometers in altitude. Did you get me? It is more than 30,000 kilometers in altitude. It will be positioned at looking at, say, for example, our one particular Indian satellite for telecommunication. It will be on India, say, for example, if it is fixed to the Bangalore or Asan station, it will be over the Asan, it will be rotating along with the Earth. It will be in phase with the Earth's rotation, it will be rotating, so that there will be no change in its position. Though it is moving, it will be moving along with the Earth, so it will be always focused, or it will be seeing the ground, particular ground station or receiving station. So that is the geostationary satellite, whereas polar orbit satellites are rotating, it is having an orbit north to south. So it will be going north to south over the Earth, and it will be stationed, it will be at the elevation, means altitude of 800 kilometers, 800, 900, 1000, within 1000 kilometers. This is quite near to the Earth, whereas the geostationary satellites are more than 30 kilometers, 30,000 kilometers in altitude. So that's why we get a little signal problem in the geostationary satellites, whereas the polar orbit satellites, we get good clarity of information. But this was not the condition. The good clarity of information was not the condition in the earlier time. It is over the period we have achieved a very big success in the satellite information. So let me go on to the how the resolution means, because the earlier the satellites had 120 meters resolution. 120 meters means one pixel used to have 120 meters of information. One pixel. So that was the information level we had. So you can go on seeing these slides. You will come to know how the resolution has improved from year to year, from 1960 onwards to the 2020. We have made a tremendous changes or transformation in the technology. So this is a particular township which is having the road, houses, and the major. I think there is one aerodrome. So the next thing is 80 meters resolution satellite. So the pixel, you can see the pixel sizes, and so it was 80 meters resolution. Each pixel had 80 meters of information, and next 30 meters of information. So we can find the pixel size as reduced, and each pixel is giving 30 meters information, and from 30 meters to 10 meters pixel, and 10 meters to 1 meter. So you can, now pixel is not visible, whereas in the, say in this, in the 80 meters pixel is visible. We cannot make out that pixel, what it is representing, whether it is representing a house, or it is representing a road, or it is representing any other object on the ground. We could not able to make it through our visible interpretation. Visible interpretation means we are not able to. It is only through the reflectance value that can be assessed, or we can identify what is the reflectance value and what will be the reflectance value of a open land, or a road, or a green plant, or dried plant. So based on the reflectance value, we could able to have the information of the ground data, but not through the naked eye. But as the resolution technologies went on improving, see, you can see the pixels are getting shrinked, and we are getting to see through our eyes. The 800 kilometers stationed satellite could able to get the information of the surface as good as our own eyes. That is the major advantage of remote sensing. So you can see now the pixel is totally gone, and we are not able to see the pixel, and it is we can see the some of the green thing. Green thing means some green lawn, or some vegetation, green vegetation are seen, and some soil kind of a thing is also seen in this resolution, and it is much more clear now. It is focused to one particular, say, one side of that township. They were means that is in the right corner of the township. There are some roads which were just in the initial picture, in the initial map. It was only the lines, it was drawn lines, but we can see now the human line is not required. We can easily make out that it is a road, so which is a good connectivity of intersection of roads. And on that road, there is some other object which looks like something terminal, aerodrome, and the different terminal of the flights to come and land and position in a systematic order. So this is a Landsat MSS satellite, 80 meters resolution grid. 80 meters. See, this one grid itself is covering 80 meters. The red mark is covering 80 meters. But in the initial stages, one pixel itself is to cover 90 meters, 120 meters. So you can see now 180 meters grid is so big on the picture. So now it is 30 meters grid. It is the spot satellite which is giving 10 meters grid, 10 meters information. Now it is 4 meters. So it is now 1 meter. And the present we have even 30 and 15 centimeters. 15, that is 0.15 meters resolution. So this is, see, this is the satellite information. This is as good as photography. This is as good as photography. We are seeing the near tower, as well as the flights and the station flight. This is 30 centimeters resolution satellite image. And this is again, you can see how neatly the stadium and the land, city development, very well planned city. It looks to be very well planned. So, this is how the satellite technology, means the remote sensing technology, has improved from time to time, and we have now 0.15 meters of resolution data. Are you clear? As the resolution increases, the information will be limited, but detailed information. That is the disadvantage. If you want to go for very high resolution, you will get a detailed information of a very small area. If you go for lower resolution, you will get a broad area information, and it will be little bit in detail. So, is there any questions regarding whatever that I have talked? If you have any questions, you can clarify. Hello?
No, sir.
No, sir.
Okay. So, if I'm boring you, just tell me. I'll just go to something which can bring mood because talking continuously about a particular aspect will also result into the intake of the brain will also have its own limitation. So we can, as I see in my research, I had done desertification process in Karnataka, the entire Karnataka desertification process research I had done, and I had to collect various information from the secondary sources. Secondary sources means from the government offices as well as the satellite data. So, sitting at my own room in my department, I could able to make a wonderful identify which are the most severely affected areas in Karnataka. So likewise, and when I completed my research and I wanted to go and check the ground reality, whether my results are true to the ground or not, because when you do some analysis and when you get some results, the unknown results. So I forgot to tell you what is the another advantage of the remote sensing means we are going to see the actual thing on the ground, and through that information we are going to get the unknown information. Say for example, as I already given you example of say for example, I wanted to buy a land which is suitable for me to grow strawberry or pista or walnut, which is all Mediterranean crop, Mediterranean region crop. I wanted to buy a land in Karnataka or in my own Mysore district, and wanted to buy that land where that kind of a suitability is available. So I can verify whether that suitable land is available in Karnataka for my own usage. So that's how we can do, and even when I did my research and I wanted to identify the desert-prone regions of Karnataka, after getting the results, I should be getting confirmed whether what I have pointed out, what I have mapped on the computer, whether it is true on the ground. I went for cross verification. I got one patch of land totally barren amidst of irrigated land. So I thought that this will be the most good testing, ground testing, because amidst of the entire irrigated land, one big patch of total barren land is I could able to see through the my analysis. So I said that if I find this barren land true to be on the ground, then my accuracy will, I can say 90% accuracy, what I have done. So I went to Raichur. After Raichur means it was that land was in Raichur. I went to the taluka place, from taluk place to the village level, means Wobbly level to, because there was no proper transportation. And after going even near to the village also, I am asking for this type of land. Is there any land which is having total barren? Because I've taken the GPS location of it. And just to encourage with the people whether they are having any information, I was just asking the people, but they were not at all aware about it. And finally, when I started approaching near to the land, then I asked the people over there. Then they said that yes, it is there in this area. So I walked through the agricultural land. I wanted to go and personally see that land, and I went over into it, and then I felt satisfied and happy that I could able to figure it out from my own office. So this is how one can able to get the information what is unknown to many. So we can identify a lot of unknown informations. We can bring, as I said, we do not know how many land is very much suitable for different type of crops. So dragon fruit is recently introduced in Chamranagara district, the two in certain pockets only. So why dragon fruit was not cultivated so far? Because there was no information. Now this technology has given us to know where exactly all these conditions are fulfilled. By this technology, we could able to identify and direct the farmers to just you go and find, means in this land is good for this kind of a crop, so which gives better returns rather than cultivating ragi, jowar, or other millets. Better you go for this type of a crop. So such kind of information we can give. It is a very good thing for the food security system. So I think just debated in order to get your attention is if I'm not boring too much on this technical aspect. So we have three types of, four types of important aspects in this remote sensing processing. That is the spatial correction, the spectral correction, the temporal and the radiometric. Means the spatial means what area that the satellite is covering, what is the accuracy level of it. The spectral means whether the we have two types of coloring in remote sensing: false color composition and true color composition. True color means what we see through our eyes, the same thing that is if it is obtained from the satellite, that is true color. Actually, the satellite sensors do not the reflected values of the ground objects are really reflected in a different wavelength. Say, for example, the vegetation reflects more energy rather than the other objects. So it is red. So it will be the wavelength of the vegetation is quite broader. And because of this broader wavelength, the actual sensor will capture it as a red composition, red color composition. So which will becomes a false color composition because the vegetation is green, but in the satellite data it will look red because of its reflection. Understand? So when we change that band, when we change that color, we know that it is surely that it is vegetation. So we put it into green. So then it becomes a true color. So that we can manipulate, but the actual satellite sensor capturing and color composition is different. That is called as false color composition. But when we are utilizing those information, we can use it as a real data, or we can even change it to our true color composition. So that is the spectral corrections what we do. The temporal means it is the time of the data that was captured, whether it is daytime or nighttime, or it is in the rainy season or in the summer season or during the flood period or earthquake or any particular month or year or date, that is temporal. Then we also look into the radiometric. Radiometric means again it is depends upon if this is the reflectance value spectral means radiometric will be color depth because this RGB itself makes 1 million color. 256 of red, 256 of blue, 256 colors of green, blue. That is RGB, red, green, and blue. 256 types of red color are there, 256 green color are there, 256 blue colors are there. So our eyes cannot able to differentiate that much of colors. If I give some 10 types of blue color, you can identify this blue is quite light, this is much more darker, this is much more darker, and you can make out some 10 different varieties of blue. But if they are powerful high means it can even go up to 15. But not more than beyond 15. But the computer can able to computer and the sensor can able to give 256 of red colors, 256 of blue colors, 256 of green color. So 256 into 256 into 256, it will give 1 million color composition. With the formattation combination of all these colors will lead to 1 million type of objects, 1 million type of color objects. Is it clear?
Yes, sir.
So this is how the remote sensing satellite sensors function, and we get this information. And the best spatial resolution, you can see already I have explained to you from the pixel level to some blur kind of a picture is available in this. And you can find the neat, clearly visible ground objects. So this is the earlier satellite data, and from that satellite, this kind of a satellite data too, we have much more improvement, and this is the latest one. As I already shown you, we can see as good as like our own photography. So I do not want to go into these different types of satellites, and just briefly, communication satellite, remote sensing satellite, navigation satellite, geocentric satellite, geostationary satellite, drone satellite, ground satellite, polar satellite, nano satellite. So all these are used for different purpose. So we are using even for navigation, there is a separate, you know that the GGPS works on, we have a consortium of 12 satellites, which will be 24 satellites, a consortium of 24 satellites, which is only dedicated for navigation purpose. So likewise, different satellites are being launched in order to get a particular benefit. So application of it, this application of the satellite data, satellite information, it is very much very wide variety. Pre-harvest crop area and production estimation. Now, actually, you see earlier there was a very great difficulty for the government officials who are at the planning level. How much food crop we are going to get from this harvest. The correct information was not available because human-based data used to be always error, filled with error. The villager content, whether he goes to the village or not, he will just by his own idea, he will write this village, some 50 acres of ragi crop, another 100 acres of some millets. So whatever the information that used to give, that used to be the source of information for any planners. What is the total production of rice? What is the total paddy? What is the total production of sugarcane? What is the total production? But now today we have very accurate data of we are not depending on any official records. It is only through satellite data. So pre-crop area, drought monitoring, flood risk mapping, the underground water level, and what is the underground water level. See, I'm again and again telling you, see the underground water, how it is connected with remote sensing, because remote sensing doesn't give the information of the underground, but it is possible. Irrigation command area development, snow melt estimation, land use land cover mapping, urban planning, forest survey, wetland mapping, environmental impact analysis, mineral prospects, coastal studies. So many more applications are there. It is all depends upon the knowledge and the conceptual knowledge what you have. You can go on extending your research and application of this data. So just you have seen this type of image nowadays in Google, but when we were constantly from our education level, from our college days, we are using map, and when this kind of a map was available to us, it was a very big what boon to say, because we never had a kind of total whatever the human developed map we had. Human developed, we used to get the globe or the world map having the different vegetation, different kind of, but we didn't had the real picture what how the earth looked like. So here in this now you can see this is the global satellite image. Everybody has got in your phone, as well as if you open the Google Earth, you'll find the whole earth, and you can from this map means this image itself, you can make so many information which how India is having, how much of portion of India is having good product, visual interpretation. We can make a lot of visual interpretation, which is the region which is quite economically strong, agriculturally strong, which is the most dried region. So all this information we can make out just by this satellite image, and you can see how the deserts are looking, and how the Himalayas are looking. So where the evergreen forest is concentrated. So what is the percentage of forest resource we have? What is the percentage of agricultural land we have? A good agriculture, irrigated land. So all information is possible from satellite images now. So this is the desert world where which portion of the globe has got more desert land. Means what is the desert land and green? The green patches shows the green land, and the yellow to bright yellow shows the desert, and the white shows the snow covered land. So this is the air pollution. This map of India, it is showing the air pollution of India. Where every day you can get the which part of the air pollution is increasing or decreasing. So all this information you can see over the Delhi air pollution is more, and near to Calcutta it is more, and I think it's this place is Allahabad or Lucknow somewhere. This is there is again it is also the air pollution is more. So this kind of when compared to this part of the India, South India is having less air pollution. So we can say that the either the traffic users are maintaining the traffic rules, and as well as the number of vehicles are less. So it is even it also depends upon the atmospheric condition also. So air pollution we can get through satellite. See, that is the good way in which we can also minimize the air pollution, and where we had to plan and all these things. So this is about again the atmospheric and forecasting information through satellite. So where the cyclones will come, see actually when compared to earthquake, which if I ask you a question whether the earthquake is most disastrous or the cyclone, you may immediately say earthquake. Which is your answer? Sandarame Gowda. Sir, what is your answer for my question?
No question, sir.
No. I asked one question.
Okay, sir.
I asked question in the this related to the satellite application and the forecasting of the weather. We if generally people will think that earthquake is most disastrous, right?
Cyclone, sir.
Cyclone.
Cyclone.
Why you call
Yes,
cyclone most disastrous?
Cyclone,
Sir,
sir.
earthquake is, I think so, sir. Earthquake is confined to a particular place where the sliding of the large
Yes.
this thing will take place. But
Right.
cyclone will just flow, sir. It will carry on. That's why.
See, now you have given a right answer. Actually, cyclone is the most disastrous natural disaster. It will be more terrible when compared to earthquake. But earthquake is becoming more terrible nowadays. Why means we cannot able to predict the occurrence of earthquake. We cannot forecast where exactly the earthquake will take place, which place, at what magnitude. This is the major disadvantage of preventing the casualties or the damage through earthquake. Whereas due to the satellite data, we can the cyclone, this one, though we cannot able to prevent the damage caused to the buildings and property, but there is no damage or loss of life in the cyclones. If you just compare the previous year's data and the present, nowadays in cyclone, only about 2, 3, 5 people died or something like that. But it was in the earlier days, it was too many used to lose their life. But now we do not have too many lives, means people are losing their life. Why we can able to forecast before 15 days. So the forecast accuracy goes on improving nearer to the event. Say, for example, in another 15 days, there will be a cyclone, means in coast, Tamil Nadu coast, Chennai coastland, means the accuracy of it will go on increasing near to the date, because the more accurate information will be available and where exactly and what time and in which direction everything can be predicted, forecasted through the satellite data. So that is how the cyclones or hurricanes or typhoons, all these are all now managed. People are evacuated before the event occurs, and they will be taken to some safe place for relocation. So we have the agriculture, water resources, and land use satellite images. So see this, each one of these maps of India is giving information of a different. See, all these are all because of the different wavelengths. Wavelengths we have having crops in India. The first green map. Then we have the information about. Means your this is about the soil map, and the next one is so different land information it is providing. So water stress, this see 54% of India faces high to extremely high water stress. Which are those portions, means you can easily figure out. So all these red colors are having water stress. There is scarcity of water for drinking as well as a total scarcity of water. So this kind of information is available for the entire India through satellite technology. So we can have the flood zones of India where the floods will occur. And this is again based on the temperature and humidity. So the heat waves. So this is all about the remote sensing technology, and how this remote sensing technology, just by having only the data, it cannot be possible for us to get this kind of a wonderful maps what I have shown. So how it is possible means there are 4 types of application platforms. So first is remote sensing data downloading. Suppose if you want to use the remote sensing application for your own study, for anything, it can, if a botany student can use it for their botany study, for a geology student can use it for geology, for climatological student they can use, for a planner, land agriculturist can agriculture. So for any purpose, if you want to use remote sensing, there are various sources. Earlier, it was only the satellite images were available only for money. But today, we do not have to pay money. There is open source satellite images are available. That is one platform. So where USGS is there, Bhuvan is there from India, and Copernicus from Europe. So likewise, different countries have given their data for free from whatever the data that is captured from the satellite. They are giving it for free. From those sources we can download. So they are uploading the satellite images and we can download. So that is one platform where we had to search and get the downloaded images into our system. After that, downloading that satellite image, it cannot be just right away useful for our purpose. It should be again analyzed, means it should be processed. As I already told you, the spectral correction will be there, radiometric correction will be there. So all these corrections should be temporal corrections. Everything should be done. That is the processing, because this image processing application is there. That is ERDAS is a very versatile application, but it is too costly. It is more than 15 lakhs for one user. Even we have the free image processing software that is Snap from Europe, Saga. There is many platforms which is image processing application, freely downloadable applications are available from the internet. So that is only to process the image in order to make each pixel is representing what type of a land information, each pixel, because it will be in the pixel format. Because if you go for a very high resolution, it is just like a photograph. No need of going for pixel level application. Only we can calculate area through that can be possible. But for low resolution, it will be in pixel, but each pixel will be an element which is representing the ground information. So in order to know which pixel is representing what type of information, then we had to do classification of that information, classification of that pixel, water body pixels, red soil pixels, which are the red soil pixels, which are the vegetation pixels. In vegetation, which crop type, whether it is paddy, whether it is sugarcane, whether it is banana, whether it is plantain, coconut. So each pixel will have a different reflectance value based on the spectral library, reflectance library. We can be able to understand, and we can make the map of, or we can calculate the area of each one of those things. So that is how the image processing application will be helpful. So after getting the image processing application, we had to use it for planning. Means that is further database software is required. Means let me open. I do not want to get into trouble by closing something. Just for your information, I'm giving all these things so that you can, not to have worry that, okay, this is available only for we people. It is available for everybody. So this is can you see my screen now? It's not visible? Screen?
No, sir.
Okay.
No, sir.
No, sir.
I just opened another slide and please.
It's blacked out, sir. It's blacked out.
Blacked out. Okay.
Black screen.
I had to share this screen. Okay, let me close this. Now we can see.
Yes.
Yes, sir.
I wanted
Yes,
to
sir.
show another slide where these 4 different what stages of processing is required or operation is required. Say I said that downloading is one way. Downloading we had to do, and we had to get the satellite image into our hard disk. Then secondly, we had to process that satellite. There is a separate application for that. Software is available. That is ERDAS or the QGS or the Saga. Many satellite. Excuse me? Somebody is talking. I'm not there. You have any questions, doubts? No? Yeah. So that is the second thing. And third thing is that you had to, it is a voluminous data. So a satellite image is a voluminous data. And for your whole Karnataka means it is a huge data. So how to store that? We had to make a database. So generating a database, and we had to make use of a separate database application software. So we can store the database and retrieve, and we can make all types of query. So database application is another sector where we had to manage this data. And fourthly, we have the GS software. GS means Geographical Information System Analysis Software. That is ArcGIS, ArcGIS we call. We have the QGIS is doing both the remote sensing processing as well as the data storage plus geographical analysis is also done by this software. So whereas this ArcGIS is, it's a powerful software which is again very costly, 10 to 15 lakhs for educational institution, and it will be much more costly for the corporate companies. For any profit oriented companies, it would be more. So this is how this satellite images has to be processed and to get the final benefit of it. So let me just what are the how this geographical information system has processed, and what are the information what we can get, that I just few. It's already 1:08. I think it's 1:15. We are closing, isn't it? 1:15 or?
No, sir. 1 o'clock.
1 o'clock, sir.
1 o'clock, sir.
Oh, okay. I'm exceeding. Okay, just I'll just show you the images, and this is the satellite images are used, and there is population change can be seen how this Las Vegas city has changed from very low population to in 1972 it has increased, 1986, so 1992. So whereas the earthquake susceptibility in Mysore city, I myself had done this. So we have made means the geological mapping we have done through the satellite images, and some of the where the geologically weak areas are present, that has been identified. And we have done some overlay analysis, and finally we have made these are the boundaries, and finally we have identified where the exact earthquake will be more seriously affecting the area. So this is about, as I already told you, the desertification in Karnataka. These are the data result data. We had to have the input data. These are the different input data we had to give. That for us, what is the water condition, underground water condition, what is the rainfall data, so drainage density map. Then finally we have achieved this, but it is not so simple. We have many remote sensing information has taken into account, and this is taluk wise I have given. This side, right side, you can see very highly affected, very high, and moderate, and very low affected desertification areas. In the map itself, you can see this part of the map, the green thing is quite low desertification area, whereas this high bright red color is indicating very high susceptibility of desertification. Desertification is going on, because the desertification itself is a huge topic that can be itself is one session talk. So I'm not going to talk much about it. So this is going to the micro level. It is Gullupete Taluk. What is the level of desertification in this taluk? Because it is most affected area in Karnataka, in Mysore district. So I have identified this also. So the causes I have identified. The city urban planning. This is again Mysore city urban planning for 100 years. Based on different parameters, I have done 3 types of planning. So just let me wind up. And so it is totally, I done some landslide analysis for Uttarakashi, and so these are the input data, and finally the output we have identified where exactly the landslide will occur and who are the people, which are the houses that is going to be affected. So such kind of means what is the total total loss of property. So all this estimation we can give to the government. These are the people who are going to be more affected, and more property will be damaged, and so that's so that they can make some other measures in order to prevent the landslide. So this kind of inventory and things I've done, and landslide. So as for myself, as involved in climatological aspects, yeah. The bell has rung, and I'm going to complete this. Sorry, I should have given you time for asking some questions, any doubts. So even now, if you have any particular